We'll be looking at the June 2024 multiple choice questions. The first question, it asks you about oxygen, which has this electron configuration. It's asking how many electrons in an atom of oxygen arranged in the p orbitals. How are the electrons arranged in the p orbitals of an oxygen atom? You see a p orbital, you've got 3 orbitals that are at the same energy level. And what we do, they get this, there's supposed to be 4 in them because it tells you in the question. And so they get filled up in a single manner first, 1, 2, 3. And the 4th electron will start doubling up. But you see that the only way 2 electrons can be in such close proximity is by having opposite spin. And so the answer is D. Next question. Water has the anomalous properties below. It's got a relatively, with comparison to other same group hydrides, relatively higher melting point and boiling point, and ice is less dense than water. Which statements explain these anomalous properties? Let's look at the answers which it cannot be. The covalent bonding within the molecule. It's got no, that the anomalous properties or these unusual properties is nothing to do with the covalent bonding within the molecule. Can't be A. The ionic bonding between the water molecules, no. It's an intermolecular force, not a strong force like ionic bonding. Even though you've got London forces between the water molecules, but it's not because of these, because all the molecules will have London forces, but these are not what cause the anomalous properties, and you're left with hydrogen bonding between water molecules. The answer is going to be B. Which chemical process is the most sustainable in terms of the atom economy of the ion produced? You see, atom economy is the molar mass of the desired product over the sum of MR of all products times 100. Quick calculation. So you've got 2 lots of 58. What is iron? The molar mass is 55.8. We're going to round this up to 56. 55.8. Just say so it's 1, 1, 2, 1, 1, 2, 2, 2, 4, 2, 2, 4. You've got 3 lots of 44. 1, 3, 2, 3 lots of 18, which is 54, 3 lots of 32, which is 66, 3 times 32, which is oxygen, that's 96, and you got 3 lots of CO2, last one, which will be again 132. If you look at all of these, the one that has the highest atom economy is the most sustainable. Highest atom economy. So if we compare, it rules these 2 out, the first 2. Let's do a quick percentage. 112 divided by 112 plus 132. That's 46%. Over 2 divided by 112 plus 54 times 100. This is 67%, which is better. We got 224. Remember, the iron is our desired product. 224 divided by 224 plus 96 times 100. We got 70% here. And the last one, 224 divided by 224 plus 132 times 100. The last one is 63. So the answer will be C. Most sustainable, meaning that there's the least amount of waste product based on its molar mass as a percentage. Which compounds of magnesium can be used as antacids? Antacids needs to act as a base because it will accept a H plus, thus neutralizing the acid. Chlorides are salts, nitrates are salts, sulfates are salts. What you've got here, magnesium hydroxide, which isn't very soluble in water. That's why you get a milky substance of magnesium hydroxide dispersed in a solution that you buy from the chemist. So the answer is B. And we know hydroxides react with acids to give you water. It neutralizes the excess stomach acid. Which statement explains the trend in boiling point down the halogens, which is group 7? You see, with halogens, you are looking at the intermolecular force between the molecules, which determines the boiling point, the trend in boiling point. Is it to do with the bond enthalpy, the bond strength within the molecule? No, it's not. Is it to do with the electron negativity? No, it's not. If you look at D, is it to do with the reactivity? No, it's not. You see, as you go down the group, there are going to be more electrons down the group within the molecule, which results in greater induced dipole-dipole forces, causing the London forces to be stronger. The answer will be C. This is a bit of a general essay question they can ask you. Explain the trend in boiling point down group 7. We can say more electrons, greater London forces, and more energy needed to overcome these. So this could be a 3-mark sort of a question as well. Which equation does not represent the disproportionation? Disproportionation is where the same element is being oxidized and reduced. Let's look at each one. Chlorine, stick to purple. Chlorine is 0 here. It goes to +1 here and a -1. That is disproportionation. Let's look at the second one. 0, +1, -1. This is also disproportionation. Let's look at the third one. This here is oxygen is -2, -2, -2. Potassium is +1. Here, chlorine is +5, -1 here, and it's +7 here. This is also disproportionation because the chlorine is being oxidized and reduced. The last one, you got -1 here, it's still -1 here, it's 0 here. Chlorine is only being oxidized. So this one is not a disproportionation reaction. Next question. The equation is for sulfuric acid and potassium hydroxide. What is the enthalpy change of neutralization in kilojoules per mole? So what we do, enthalpy change of neutralization. It tells you the energy given off. So in this reaction, it reacts with excess potassium hydroxide. So we're looking at the sulfuric acid. So it's going to be 0.25 times 2.8 kilojoules, and we divide that by the number of moles. Which will be 25 over 1000 times 1.00. Let's see what this gives us. 2.8 divided by 0.025. That gives, you see, that gives you energy is given out, so that's minus 112. That's what a lot of you will work out, actually, which points at answer C. Answer C will be a common answer given, however, it is wrong. Entropy change of neutralization is where 1 mole of water is formed from a reaction between the acid and the base. Here, you've got 2 moles being formed. So we need to halve that amount. Half of minus 112 is minus 56. So here, not knowing your definitions can make you lose the mark. Which row in the table explains how catalysts affect the activation energy and the proportion of molecules with energy greater than activation energy? Even though it's not asking for, but if you look at the Boltzmann distribution, here you've got the number of particles. And here you've got your energy. You've got your shape looking something like this. You've got your activation energy. And when we're using a catalyst, let's call it EC, it lowers the activation energy, giving you a greater proportion of molecules that now have energy greater than the activation energy. So the activation energy decreases, and the proportion of molecules with energy greater than activation energy is going to increase. So the answer is B. In this question, a graph, we're using the Arrhenius equation. And when you take natural logs of it, you've got this relationship, natural log K is equal to minus EA over R times 1 over T plus natural log of A. So you got Y equals M times X plus C. You see the gradient, they've given you that. This is the gradient because it's M. And how do we get activation energy? It's going to be minus 1600. We're going to multiply this by minus R, which is 8.314. This gives us 133,024. But the thing is, this is in joules per mole. And to convert joules to kilojoules, we need to divide by 1,000, which will give us the answer B. Next question is asking about the zero order with respect to a reactant. Which rate concentration graph? Rate concentration. So you've got your rate on your y-axis, and you've got your concentration on the x. A zero order means no matter what the concentration, the rate of the reaction is unaffected. Let me highlight that. No matter what the concentration, the rate of the reaction does not change. The answer will be D. This is an equilibrium question. The graph shows how the concentrations of the reactants and product change as the reaction reaches dynamic equilibrium. At which point on the graph is the equilibrium reached? You see, one of the features of dynamic equilibrium is where the products, the concentration of the products and the concentration of the reactants remains constant. When is that constant amount reached? It's reached at this point, C. You see, after that time, the product and reactant concentration is constant. Therefore, the answer will be C. Which solution can be added to a weak acid like ethanoic acid to make a buffer solution? You see, a buffer solution can be made either by a weak acid and its salt, or a weak acid, excess weak acid reacting with a base, which produces some salt, and you're going to have excess weak acid left over. So in this case, out of these options, the only option we have is the salt. Salt, so it's weak acid, and it's salt. Sodium ethanoate. A student analyzes a solution of a salt. The results are shown below. You see, it's one of these four. We don't know which one. You see, out of all of these, reacting it with NaOH, the precipitates, you need to know your colors, by the way. This would give you actually a blue precipitate. It's a bit of a, this gives you a blue precipitate. This is with NaOH, blue precipitate. Iron 2 chloride would actually give you a green precipitate. And this gives you a sort of a orange-brown precipitate. So they've said here it's actually a green precipitate. So it's, whoops, I just realized that the D is actually also a green precipitate because it's also a 2+ ion. I thought it was a 3+ ion. So it narrows it down to these two. And the fact that with barium nitrate solution, it produces a white precipitate, this is actually a test for a sulfate ion. Which one of those two is a sulfate ion? It is D. So using year 1 and year 2 qualitative analysis. Next question. Chlorine has the electron configuration there. Which statement about chlorine is or are correct when it reacts in a redox reaction? It can gain 1 electron to form these ions. It can lose electrons, or it can lose... so which is asking which one of these is actually correct? You see, chlorine has a tendency to gain 1 electron. Its electrons are lost when it's only bonded to oxygen, but it doesn't form individual ion itself. So the answer is actually 1. The answer will be D. Let me just explain that. You see, with it can't lose these 3s2 electrons or 3p5 electrons to form these lone ions. Though it can have oxidation states of a +5 and a +2, but it doesn't form those ions. A bit of a tricky question, actually, this one. Last question. Which statements about the elements in the periodic table are correct? This is a year 1 question. The position of an element is determined by its relative atomic mass. No, it's not. It's based on its atomic number, which is the symbol AR. The element in a group have similar chemical properties. Yes, they do, because they have the same number of electrons in the outer shell. Transition elements are used as catalysts in the manufacture of chemicals. Yes, they are. It's got nickel in the hydrogenation of an alkene. You've got iron in the Haber process. Which other ones have you got? You got there's manganese 4 oxide. There's a few others. I think there's vanadium as well in various processes. But yes, this is correct as well. So 2 and 3 only. That's the multiple choice questions. See you later for the next question.